Assalamu alaikum viewers. I'm back with another video. In this video, I will teach you about different types of functional groups which are found in organic compounds. This video is part 2 of my previous video in which I taught you about concept of functional groups, alkyl groups and importance of functional groups. This video is going to be quite interesting and helpful for those students who feel difficulty in understanding and identification of functional groups. This is because if you cannot understand functional groups, you cannot understand organic compounds and their reactions. Before starting different types of functional groups, I will like to explain you about nomenclature. This part of the video is going to be very interesting and helpful because most of the students are found in difficulty regarding the understanding of name of an organic compound. If you cannot understand the name of an organic compound, you cannot understand its chemical reactions and functional groups it contains. I will not go in the detail of the nomenclature as it is a very complex topic. I will simply give you some important tips and tricks to understand the naming of an organic compound. The name of an organic compound, it gives us two types of information. This is very important and I request you to listen to this thing very carefully. The name of an organic compound, it normally gives us two types of information. I'm talking about a very simple name, not talking about complex name, a complex compound which contain a lot of branches. No, I'm simply talking about a very simple compound like methane, ethane, propane, butane. Because if you understand the naming of these simple compounds, you will be able to understand the naming of complex compounds as well. So, the name of an organic compound, it gives us two information. The first information it gives is about the number of carbon atoms an organic compound contains. I will repeat again. The first part of the name of an organic compound gives us information about the number of carbon atom it contains, while the second part of the name gives us information about the functional group present in the organic compound. Now these are the two very important and vital informations which we can simply get from the name of an organic compound if we understand the name. So here you have a table. This table will help us to understand the naming of an organic compound. If you have one carbon in your organic compound, then the name of that organic compound will start from the word meth. Or we can say that the word meth will be there at the start of the name. So whenever you hear the word methane, then it should simply straight come into your mind that the given organic compound contains one carbon atom. For example, we have methane. Methane, CH4, is a natural gas. All of you know about methane. So, from the word methane, we can simply say that the first part of the word meth means it contains one carbon atom. This is a very vital information. Secondly, if the organic compound contains two carbon atoms, then the name of that organic compound will start from the word eth. Like in ethane. Here in ethane, the word eth means two carbon atoms, while the word ane is explaining the function group it contains. We normally use the word ane for carbon-carbon single bond. Whenever there is carbon-carbon single bond in the organic compound, we use the word ane at the end of that organic compound. Similarly, the word prop is used to indicate the presence of 3 functional groups, 3 carbon atoms in the organic compound. Like in propane. In propane, the word prop means 3 into carbons, and ane means we have single bond among 3 carbon atoms. In butane, we have 4 carbon atoms. That is why the name of the butane starts from but. So whenever we have 4 carbon atoms in an organic compound, the name will be starting from but. If we have 5 carbon atoms in the organic compound, the name of the organic compound will start from the word pent. I hope so. This part of the video will be clear to you now. So I also have given some keywords for your understanding and learning. The keyword is MAP-BP. It will help you to understand and learn these 5 words. MAP-BP. Here, these are the words which are just created for your understanding. You can make your own keywords for your own understanding as well. MAP-BP. In MAP, the first word M means math. The second word E means ath. The third word letter P means prop. The fourth letter B means but. And the fifth letter P means pant. I hope so. Now, if you just hear the name of an organic compound, you would be in a position to tell that how many carbon atoms it contains. The second part of the table, it gives you further information about the naming of the organic compound. If you have 6 carbon atoms in your compound, the name of the compound will start from the word hex, like hexane. If you have 7 carbon atoms, the naming will start from the word hept, like heptane. So whenever you will hear the word heptane, it should straight come into your mind that the given organic compound has 7 carbon atoms in it. Similarly, if we have 8 carbon atoms in an organic compound, the naming will start from the word oct. If we have 9 carbon atoms, then the naming will start from the word non. And if we have 10 carbon atoms in our organic compound, the name of that organic compound will start from the word dec. So if you hear the word decane, then it means from the word dec, you can simply tell it contains 10 into carbon atoms, and from the word ene, you can tell it has single bond among all the carbon atoms. I have again written few keywords for your understanding. You know about the motorbike Honda. If you remove the A, last A from the Honda, you will get horn. You will need to add an extra H in the front. So from the word horn, we can learn these 5 letters which will help us to understand the naming of the organic compound. In horn, the first H explains hex, the second H explains hept, O explains oct, 9 and N stands for non, and D stands for dec. I hope so. Now, these keywords will help you to understand the naming of an organic compound. Well, after understanding or having an idea about the naming of an organic compound, I would like to teach you about function groups. Again, I have arranged these function groups from easy to complex one. First of all, I will start from 4 function groups which are starting from the letter A. First, one of them or first is carbon-carbon single bond. Whenever there is carbon-carbon single bond in any organic compound, then the new organic compound produced is called alkane. And we normally place the letters A and E, the word ane at the end of the name of an alkane. So, if you find carbon-carbon single bond anywhere in an organic compound, then it should automatically come in your mind that it is an alkane. Like for example, ethane. In ethane, the word eth represents that there are two carbons, and ane shows that they have carbon-carbon single bond. The keyword to understand or remember alkane is A. Secondly, carbon-carbon double bond. Whenever you feel or you find an organic compound which have carbon-carbon double bond between the two carbon atoms, the new compound produced is called an alkene, and the name of the alkene normally contains ene at the end, like in ethene. So what is the difference between an ethane and ethene? Is the presence of function group. In ethane, the function group is carbon-carbon single bond, while in ethene, the function group is carbon-carbon double bond. The third function group, starting from the letter A, is carbon-carbon triple bond. So whenever you find carbon-carbon triple bond in an organic compound, then the new organic compound produced is alkyne, and the name of that organic compound ends at -ine, Y-N-E-ine. Like example is ethyne. In ethyne, the word eth means two carbon atoms, and ine explains the two carbons carry triple bond between themselves. Again, the keyword to learn it is A. The last function group, which is starting from the letter A, is alkyl group. An alkyl group is rather very different from the other three, because an alkyl group is normally unstable, while alkane, alkene and alkyne are relatively stable. An alkyl group is produced when we remove one bond from an alkane. After the removal of one bond, the carbon of the alkane has ability to make one into bond. The new group produced as a result of removal of the one bond is called alkyl group, and the name of the alkyl group carries the letters Y and L at the end of the name. Like for example, CH3 is produced when one hydrogen is removed from CH4. The new alkyl group now produced contains one carbon atom. That's why we have used the word meth at the start, and the letter YL completes the name. So the new name is methyl group. So now when you hear the word methyl, it should come straight into your mind that the word meth means this group contains one carbon atom, and the letters Y and L shows it is an alkyl group, that is methyl group. We normally represent an alkyl group with R, as the word A carries the start of alkyl group, so I have also included it in the category of those functional groups whose names start from the letter A. We have studied 4 into functional groups which are starting from the letter A. And the collective keyword to remember them, or the key letter, is A. After studying some simple functional groups, now I will move towards some not very complex, relatively different functional groups. The first functional group in this category is halogen group. Halogens include fluorine, chlorine, bromine, and iodine. They are normally symbolized with the word X. Whenever an halogen gets attached with an alkyl group, we get new organic compound which is called alkyl halide, as it contains both alkyl group and halogen group. As far as naming is concerned, the naming of these organic compound contain halo at the start to indicate the presence of an halogen atom rather than a halogen as a function group. While the word halo is followed by the name of alkane, which carry the halogen atom, like methyl chloride, CH3Cl. Methyl chloride is the common name, while the IUPAC name is chloromethane. In IUPAC, the name of halogen will be named first and it will be followed by the name of alkane. If we have bromine in place of chlorine, then the name will be bromomethane. Or if we have ethyl group in place of methyl group, the name will be chloroethane. The keyword to remember this functional group is H, as halogen contain H as the first letter. The second functional group is hydroxyl group or OH group. Whenever an hydroxyl group gets attached with an alkyl group, the new organic compound produced are called as alcohols. Now you will be noticing one thing, that in this category of organic compounds, alkyl group is common. The only thing that is different is the presence of functional group. Whenever halogen is attached as a functional group with alkyl group, we get alkyl halide. Whereas whenever hydroxyl group is attached as a functional group with the alkyl group, we get alcohols as a new organic compound. The naming of alcohols carry the word ol at the end, like CH3OH. Common name is methyl alcohol. But to name them according to IUPAC, we remove the word E from the methane and we will add OL at the end to indicate the presence of an hydroxyl group in an alkane, methanol. Now it is an alcohol. The keyword to remember methanol or rather alcoholic group is again A. The third functional group in this category is amino group. Whenever an amino group like NH2 gets attached with an alkyl group, the new compounds produced are called amines. Their name is relatively simple, like CH3NH2. Commonly, we can call it as methylamine or aminomethane. The word A again represents amino group. The fourth functional group is nitrile group, CN group. We also call them as cyanide group or cyano group. Whenever an alkyl group gets attached with a cyanide group, the compound produced are called cyanides or alkyl cyanides or simply nitriles or alkyl nitriles. Their name is relatively simple. They may be called as methyl cyanide or methyl nitriles. The key word to explain them is N. The next functional group is thiol group. They are just like alcohols. The difference is that in alcohol the functional group is OH, while in thiol the atom oxygen is replaced by the atom sulfur. Normally, the compounds which contain sulfur as one element in them are called thiol compounds. That is why this group is called thiol group, due to the presence of sulfur atom. So whenever a thiol group gets attached with an alkyl group, the new organic compound produced are called thiols. They contain SH group. That's why they are named as thiols. The naming is simple. We simply place the word thiol at the end, like Cl3SH. It is methane thiol, a methane carrying SH as a group. The word T is used as a keyword can be used as a keyword to remember them. Now these 5 functional groups which we have studied so far were relatively easier groups because in all these groups the pattern was same. There was an alkyl group which was getting attached with another new functional groups and a new organic compound was produced. But the next 2 functional groups which we will study now, they are relatively different from the previous groups. In order to understand these functional groups, rather in order to understand ether group first, I will like you to take the example of water molecule. Simply remember or visualize water molecule. All of you know the formula of water molecule, that is H2O. It carries 2 hydrogen and 1 oxygen atom. We know that oxygen has ability to make 2 into bonds. So if we remove 2 hydrogens from the water molecule and we add 2 alkyl group in place of 2 hydrogen atom, we will get a new group that is called ether group, ROR, where R represents alkyl group which have replaced 2 hydrogens of water molecule. Ether group is also called as a derivative of water molecule. So whenever you find 2 alkyl groups surrounding an oxygen atom, it will come straight into your mind that it is a derivative of water molecule, so it is called an ether. Example is CH3O C2H5. The naming contains oxy and ane. The word oxy is used to indicate the presence of oxygen atom, while the word ane represents an alkane. Like for example, in CH3O C2H5, we have 2 alkyl group methyl and ethyl and oxygen in the center. The oxygen will be named with that alkyl group which carries less number of carbon atom, which in our case is methyl group. So it is methyl plus oxygen makes methoxy, while the rest of the group C2H5 is considered as an alkane, so the name will be methoxyethane. And the keyword E is used to represent ether group. I hope so it will be clear. The next group and the last group in this category is epoxy, rather we call them as cyclic oxides, normally epoxides. These epoxides are the cyclic oxides which carry oxygen as one of the member. In order to remember them or understand them, I would like you to visualize ethene molecule or any alkene. For simplicity, we can take the example of ethene molecule. In ethene, there is carbon-carbon double bond. If we remove one double bond from alkene or from ethene, then both the carbon atoms of the ethene gets ability to make 1 into bond. So they get attached with the oxygen atom which has ability to make 1 bond. And the new compound produced contain oxygen with the 2 carbon atoms attached with it. Now it is called as epoxide and the group is called epoxide group. They are called cyclic oxides as well, and they contain a triangular shape in which oxygen is one of the member. They normally carry ene to explain the presence of alkene and oxide to indicate the presence of oxygen in their name. Like example is CH2 oxygen CH2. Now this compound is an epoxide because it carries oxygen with 2 carbon atoms. It is cyclic in nature, so it is produced from ethene. So we will use the word ethene at the start and it will be followed by the word oxide to indicate the presence of oxygen. If we have propene in its place, then the name will be propene oxide. Normally, to remember the epoxides, we use the letter E as a keyword. Dear students, before signing off, I would like to give you some keywords which would help you to remember these 7 functional groups that we have just studied, and I have arranged them in order of ease of understanding or ease of remembering these keywords. The first group in this regard is ether group. The keyword is E. The next is thiol group. The keyword is T. Then followed by halogen group. The keyword is H. Then alcoholic group. The keyword is A. Amino group. The keyword is A. Nitrile group. The keyword is N. And at the last E, that is for epoxide group. So if you spell out these keywords, it will make the words collectively, they will spell out as ethane, and ethane with an extra a added to it. So from the word ethane you can remember these 7 functional groups, and I hope so it will be much clear to you. So if I summarize the whole functional groups we studied today, so we studied first 4 functional groups, which started with the letter A. Then we studied 7 functional groups, so total become 11 functional groups. So I would request you to remember these 11 functional groups and practice them again and again through the keywords. If you have any query, you can write me in the comment section below. In the next video I will bring the concept of carbonyl group and different functional groups which make carbonyl compounds. Please do like and subscribe my channel. Thank you so much for your time.